Hello everyone, I am Zhang Yu from Southwest Petroleum University in China. My research interests include the theory and the application technology of oil and gas stimulation. I am delighted to have this opportunity to share something with you. Today, I will focus on prediction of shale apparent liquid permeability based on Fractal theory. This article has been published in the Journal of Energy and Fuels. The reference as follows. My presentation includes the following parts. First of all, I will give a brief introduction to our research background and object. For the second part, we will introduce the specific establishment process of apparent permeability model. The third part is model validation. The first part is results and discussion. The last one is conclusions. First of all, I will give a brief introduction to our research background. Flowing back, the fracturing fluid is the last step of hydraulic fracturing process, and water trapped in the fracture network is to confine the nanopods through spontaneous inhibition, which is regarded as the of the low volume recovery, and improve understanding of the fluid flow behavior in large-scale pods is critical to forecast the recovery in unconventional reservoirs. Notably, three pore types are found in shale-purpose matter, inorganic pods, and organic pods, and the size of inorganic pods is 20 nano to 4,000 nano. What's more, the size of organic pods is 5 nano to 200 nano by scanning electron microscopy. So we can simplify the shale-purpose matter to mainly nanotube capillary. For the second part, it is our methodology. Further establish Hagen-Poiseuille flow equation with the slip effect. We consider two choice capillary effect, slip effect, and can find lateral fluid flow viscosity. We use Fractal theory to transition to the single pulse flow equation to shale purpose matter. Similarly, we reveal the water transport mechanism in shale. So considering viscosity changes with lattice size and organic matter content. Finally, we set up the apparent liquid permeability model by the generated laser law. The details as follows. For the established Hagen-Poiseuille flow equation, we consider the two choice capillary effects, slip effect, and can find the lateral fluid flow viscosity, and we can get a new flow equation. Then, shale purpose matter can be described as being composed of fractal objects. Thus, in the cross-sectional area of unit cell of fractal purpose matter, the cumulative size of n pods, whose pore size are equal to or larger than lambda, satisfies the fractal scaling law. And we use fractal theory to transition the single pulse flow flux to shale purpose matter. Due to the capacity, the integral formula, we divided the upper and lower limits of the integral into a large sum of small parts. Additionally, we consider with the cost change with nanopore size and organic matter content. Finally, we set up the parent liquid permeability model by the generalized Dudley law. The third part is model validation. First, we have a single category permeability comparison of the models of one and type model. And we have the proposed LP model comparison of the models of one and type model. From the figures, the proposed apparent liquid permeability model fits well with the type and one model. What's more, we have the experimental verification with quartz scan Thomas's data. It can be seen from the figure that the model in this paper is in good agreement with the experimental data. The first part is my results and discussion. First, it is visually effect. The LP model enhancement factors are significantly lower than 0.1 in organic matter, but the enhancement factors improve dramatically from 90 degrees to 180 degrees. Secondly, it is very viscosity. The viscosity resulting from the liquid-liquid and solid-liquid interactions significantly alters the water transport capability in organic matter, which should be carefully addressed in Shale research. Thirdly, it is fractal per dimensions. From the figures, it is clear that the LP gradually decreases with increasing df and dt. The two-trace fractal dimensions of a shale formation requires the formation heterogeneity and tortuosity and a larger tortuosity fractal dimensional implying a more heterogeneous matter, which has a smaller LP. The last one is concluding. First, the multilayer sticking effect induced the weaker water molecules reduce the shear purpose matter lattice size and decreases the LP of the hydraulic in organic matter. Secondly, the LP enhancement factors increases sharply as the content angle increases, especially when the contact angle is larger than the 140 degrees. Thirdly, the fractal dimension is another important factor influencing the LP of shear purpose matter. The LP decreases gradually with the increased dF and dt, determining the geometric factors of shear purpose matter is helpful for its estimating the shear purpose matter LP more accurately. This research was supported by the National Science Foundation of China and the National Key and Development Program of China. And this article has been published in the Journal of Energy of Fuels. The above is all the contents of my report. Thank you for your attention.